Okay, so projectile motion. There are three types of questions that you could be asked. The first type of question is something going from the ground back to the ground. So the object is going to start at ground level, projectile, and come back to ground level. This is the simple type. Information you should be given in this type of question will be, you'll be told the initial velocity and most likely, and an angle. You'll definitely need an angle, and you'll need the initial velocity in at least one direction, but probably this direction. So let's look at an example. So, if we've got a projectile that is launched going, let's say, 10 meters per second at an angle of 60 degrees from the ground. So this projectile goes, and you'll be asked to find, you could be asked to find how high it goes, the time it takes, and how far it goes. So the first thing you'll need to do is find out how high it goes. So let's work out how high our projectile's gone. Split this into its components. So of the 10 meters per second, that's 60 degrees. So for this side being the opposite, using trigonometry, we use the sine. So our vertical up speed is 10 times the sine of 60, which equals 8.66 meters, and our horizontal velocity is equal to 10 times the cosine of 60, which equals 5 meters. Right, so now that we have our velocities in their components, we can start using these. So what we need to do first is find out how far up our object goes. Now we have initial velocity, we have final velocity, because at the top the final vertical velocity will be 0. We have the acceleration, and I'm looking for x. So we use v squared equals u squared plus 2ax, because we have v, u, 2 is a number, and we have a, and we're looking for x. So let's put some numbers into this. So we've got v squared, final velocity, 0, equals our initial velocity, 8.66 squared, plus 2 times negative 9.8 times x. Now 9.8 being negative because it's accelerating downwards the opposite direction of our speed. So we rearrange this, pull these two bits over the other side, so that gets them back to being positive. So we've got 19.6x equals 8.66 squared. So then our x is equal to 8.66 squared, all divided by 19.6, which if you type that into a calculator should get you 3.83 meters. So that's how vertical height. Then to find the time. So to find the time, we use a much simpler formula. We can use v equals u plus a t. Because we have v and u again, we have a, and we're trying to find t. So, we've got 0 final equals 8.66, our initial, plus negative 9.8 times t. So then if we, again, we'll put this bit onto the other side, so that gives us 9.8 t equals 8.66. Moving the 9 over, t, dividing that through, t equals 8.66 divided by 9.8, which equals 0.884 seconds. So that's the time it takes to get up to the top of its flight. So now we have how high it's gone up here, and the time it took to get all the way up here. Now, because we know that if it's going from this height back to this height, it'll take the same time to get up as it takes to get down. So the time for the total flight is just twice this. And then we can use that with the basic formula for velocity, v equals x on t, then means that x is equal to velocity times the time, and we have the initial velocity horizontally from working out the components. So the velocity horizontally is 5 meters per second, and our time is 2 lots of 8.44. So to find the horizontal distance that it covers, our new x equals 5 times 2 lots of our time, 0.884, which, when you type that all into your calculator, gives you 8.84 meters. So there we have it. It's the horizontal distance. So the three things you have been asked to find were the distance it goes up, our distance vertically, which we found out to be 3.83 meters. You've been asked to find the time of the flight, which equals 1.768, or if you're asked to find the time of just up, the time just up was 0.884, and the distance horizontally, which was 8.84 meters. The next type of question will be going straight from a height, so travelling straight from a height to the ground. So that is man running off this ledge. Alright, this one is a much simpler question. If we have our man or just object going off a height to the ground, you could be asked to find a few things. You should be given the initial speed, so you should be given v for u, and you will be given the height. So in this example, let's pretend he's going, let's say he's going 8 meters per second that way, so horizontally, and the height can be 10 meters. So the things you'll be asked to find here will be how long does it take to fall, how far does he travel horizontally, and what's his final velocity. So finding the time it takes to fall, we have, what do we have? We have u, we know that to be 0 vertically. We know that the vertical height is 10 meters. We know that acceleration is 9.8 meters per second. per second, and we're looking for t. So all that tells us to use x equals ut plus half at squared. So let's put some values into this formula. So putting the values in gives us 10 equals 0 times whatever the time is, plus half times 9.8 times the time squared. So we can rearrange this, I'll simplify it a bit first, so 10 equals 4.9 times t squared. So we can get t squared by itself by going 10 divided by 4.9 equals t squared. So therefore t equals the square root of 10 divided by 4.9, which comes out to be 1.43 seconds. So that is our time that it takes our object to drop from the top of the cliff all the way down to the bottom. Now once we have that, finding how far it goes horizontally is nice and easy. Using, again, x equals vt. We now have t and we have v because that's in the question. So that's just 8 times 1.43. We don't have to double this time, the time, because it's just got the one half of the fall, one half of the parabolic motion. So 8 times 1.43 gives us 11.44 meters. So that's how far it goes across this way, the horizontal distance. So all we're asked to find then might be the final velocity. So to find the final velocity, we first need to find the final velocity in the vertical direction. So to do that, let's go see what we've got. So we know that vertically the u is initial velocity, 0. We know the time it takes to fall, and we know the acceleration, so we can use v final velocity equals u plus at. And if we put some numbers in that, we get u 0 plus 9.8 times our time, which is 1.43 seconds. So our final vertical velocity is 14.014 meters per second. That's our final vertical velocity. If you're asked to find the final overall velocity, this is where you need to do the reverse of putting things in their component vectors. So we have velocity of 14.014 meters per second downwards, and a horizontal velocity of 8 meters per second. So then our overall final velocity, by adding these two vectors down here, we can find just using Pythagoras. So we've got our final velocity squared equals 14.014 squared plus 8 squared. So if we add them together, we get 260.398 from our calculator, and then we take the square root of that to find that v equals 16.137. So that's our final velocity. If you are asked to find the direction, so the angle here, we just use that. This is the opposite side of the angle, and this is the adjacent side, so we use tan, which because tan theta equals opposite over adjacent. So then theta, using our inverse trig, equals tan inverse of 14.014 divided by 8, which if you put that into a calculator gives you 60.28 degrees. And that's all you could be asked to find for that type of question. So, the final type of question, the trickiest, is if we have type 3, projected from a height to the ground. So this is the type that we were looking at in class when we were throwing things. This is the situation where we'd have a person throwing an object that would then fly at the ground. So it doesn't go back to the same level where it started, it actually goes further. Now, for this question, you would need to not only be told the initial velocity and the angle, but you should also be told the height. So the height of the person or the height of whatever the object is launched from. So, let's go with a person throwing the object. Now, for simplicity's sake, we'll say the object starts at 10 meters per second at an angle of 60 degrees, just like in our first question. And we'll say that the height of the person throwing the object is 1.5 meters. So, we can imagine the object going, getting back to here, and then dropping the extra 1.5 meters to the ground. So, how do we solve this question? Well, the first part is pretty easy. All you have to do initially to find the maximum height is you just do exactly the same thing as you would ground to ground, but you just have to add the height of the person to it. So that's easy. Time it takes to get to the top, again, is exactly the same as you would before. You don't even have to add anything. The only difference comes when you start to try and find the horizontal distance. What you have to first do is work out the time it takes to get down. So this is where it starts to get a little bit different, but not too bad. So the time it takes to get down, we know the distance it's trying to get down because we found out how high it goes up. From the previous question, we found that it goes 3.83 meters up from where it's launched. So we get its maximum height is 3.83 plus our 1.5 meters that it is off the ground initially. So its x is 5.33, just by adding them together. So now we have x, we have the initial velocity u, we have acceleration, and we're looking for time. So we use the same formula as we did before, we just have a different x. So we've got x equals ut plus half a t squared. Again, same formula we did before, we just had to adjust the x value. So now we've got 5.33 equals 0 plus half of acceleration, so half of 9.8 is 4.9 times t squared. So again, we can get t squared by itself by going 5.33 divided by 4.9. So then our new time to come down is equal to the square root of 5.33 divided by 4.9, which equals 1.043. So that's the time it takes to get from the top of its flight, up here, down to the ground. Not back to level, to the ground. So, now we can work out the total time it takes for the flight. So our total time is equal to the time up plus the time down. So it's equal to 8. Sorry. It's not. Our new total time is equal to 0.884 plus 1.043, which equals 1.927. So that's seconds. That's our new total time. And then to work out how far it's gone horizontally, again we just use this new time in the same formula, in x equals vt. So that gives us x is equal to horizontal speed, which was 5 meters per second, times our new time of 1.927. So our new horizontal distance is 9.635 meters. So yeah, so this question is much the same. You just have to adjust the time, find that different time it takes to get down, because it will be not the same time it takes up, and then just use that time to find out horizontal distance. Nice and easy. And that's the 3 types of questions you could be asked on projectile motions.